So I was working on this topic with a student today and I thought this would make a great video for my channel because this always comes up, mainly in the GRE but also in the GMAT, and it comes up so much that I would say it's likely to come up once in your test. What am I talking about? I'm talking about circles being inscribed within squares and squares being inscribed within circles. Just quickly, what does that word inscribed mean? It means drawn inside of the other shape with its corners touching the edge. So a circle inscribed within a square isn't just a tiny little circle anywhere inside the square. It's a circle where the points on the circumference touch the edges of the square. We'll see this in diagrams in a moment. What's also true about this topic is that almost every student I meet gets this topic wrong when they first meet it in the test. So it's a very valuable video for a lot of people, I think. Take a question like this. This is a slightly easier question, then we'll do a harder one, and finally there'll be a boss level question for those really looking for a challenge. What about this question? A circle of area 36 pi is inscribed within a square. What is the perimeter of the square? Step 1. Let's draw this out in a diagram with a circle being inside a square with its edges touching the edge of the square. So always do a diagram just to help yourself out. Here's my diagram. Now this is a slightly advanced level topic, so I'm going to assume you know how to set up equations. For example, it tells us that the circle has an area of 36 pi, and therefore we write the equation without them asking us to. 36 pi equals pi r squared. That's the formula for the area of a circle. That's the equation that we write down and that we're going to solve. Cancel out the pi's on both sides, square root, and we now know that the radius is 6. A circle of area 36 pi has a radius of 6, and if we know the radius, we can work out the diameter. As I've written down in blue there, always watch out for diameters. This entire video, this entire trick revolves around finding diameters. So diameters are really important when we're dealing with inscriptions. Either way, the radius is 6, so the diameter is double of that, which is 12. And if you look at the diagram, that diameter of the circle is the same as the side of the square. Horizontally, that diameter equals the side length of the square. Therefore, for this shape, we know the side length of the square is also 12. And if the side length of the square is 12, what's the perimeter? Always check back to the question to see what they're actually asking. The perimeter means all the way around the edge. That's 12 plus 12 plus 12 plus 12, or 12 times 4, which is 48. Right, that was a nice warm-up question, but the next one's going to be harder. I always find circles inscribed within squares easier just because it's quite clear that the diameter equals the side length of the square. But what about squares inscribed within circles? You can pause the video and try this one yourself, but it does involve a couple of tricks that I haven't yet come to, so do your best and good luck. Most of you, however, will want to watch the explanation. So we have a square perimeter 16 centimeters being inscribed within a circle. What is the circumference of the circle? Now we're going to do a diagram, but there's something quite important about my diagram that you might notice. I've drawn a diagonal for the square. Why is that? Because that diagonal equals the diameter. So I'm sure that you drew a square touching the edges of a circle, inside a circle. But I encourage you to draw that diagonal because that diagonal equals the diameter. As I said in the previous slide, always try to find diameters when we're dealing with inscribed circles and squares. That diagonal, that diameter, is the one thing linking the square with the circle. So we know that the square has a perimeter of 16, and if the perimeter is 16, of course we can work out the side length. The perimeter is 16, each side of the square is length 4 centimeters. But how does that relate to the diagonal of the square? Now here's my first trick. Many of you are expecting me now to say, do Pythagoras and work out the diagonal, the hypotenuse. But there's a shortcut. Yes, we can do 4 squared plus 4 squared equals c squared and then work out c. But I want to tell you a secret known only to insiders. If you didn't know the secret, please do leave a like and a comment after you hear the secret. The secret is that the diagonal of a square is always root 2 multiplied by the side length. The diagonal of a square is always root 2 multiplied by the side length. So if we have a side length of 4 for the square, all we have to do is multiply that by root 2 and instantly we know the diagonal of the square. Notice there was no need to do Pythagoras. If the side length, if one side of the square is 4, we know the diagonal is 4 root 2. A little hint, which may or may not be useful for the next question, is if you have the diagonal of the square, you can divide by root 2 to find the side length. It's this same rule in reverse. No need for Pythagoras. If you have the side length, multiply by root 2 to get the diagonal. If you have the diagonal, divide by root 2 to find the side length. Anyway, we're getting distracted. For this square, we have a side length of 4, and therefore we have a diagonal of 4 root 2. And, as we've seen from earlier, the diagonal of the square links to the circle because the diagonal equals the diameter of the circle. So we know the diameter of the circle is, as we said before, the same as the diameter, which in this case is 4 root 2. If the diameter is 4 root 2, of course the radius is half of that, which is 2 root 2. And now let's refer back to the question to see what they want. Do they want the area? Do they want... Here they want the circumference. What's the formula for the circumference of a circle? Can you tell me? 2 pi r, and the radius is 2 root 2. So we simply insert that radius, that r, 2 root 2, into the formula for a circumference. Circumference is 2 pi r, our r is 2 root 2, and so we have 2 pi times 2 root 2. I know that's a lot of 2's, but basically 2 root 2 times 2, if you ignore the pi, is 4 root 2. So just write 4 root 2 with a pi at the end, and that is the circumference of the circle. By now, I know many of you are just giddy with excitement and thinking this is an amazing trick. And if that's true, please do leave a like and a comment as always. But for those really looking to tackle the most challenging of GRE and GMAT questions, try the next one on your own. This I've called boss level. A square is inscribed in a circle of circumference 8 pi, shown below. What is the area of the shaded region in blue? Pause the video, take your time. It will probably take you at least 2 minutes, if not 3, to get this right. And if you do get it right, that's a lot of credit because it's the hardest type of question they can ask you. For those who want to hear me do it, I'm about to start that now. So they've told us the circumference is 8 pi. So we immediately set up the equation. 8 pi equals 2 pi r, divide by pi to both sides, 2r equals 8, so the radius is 4. As we've learnt today, always find the diameter. So if the radius is 4, the diameter is 8. What we've also learned is when a square is inscribed within a circle, the diameter is the same as the diagonal of the square. You could draw that going across if you want. So we know the diagonal of the square is 8. But there's not much we can do with the diagonal of a square. We would much prefer to know the side length of a square. Can you remember from the previous slide how we get from the diagonal of the square to the side length of the square? It would be divide by root 2. Remember, to get from the side length, the short side length of the square, to the diagonal, you times by root 2. But if you have that hypotenuse, if you have that diagonal, to get to the shorter side length, you divide by root 2. So here, if the diagonal is 8, we divide that by root 2 and get 8 over root 2 as the side length. We may need to simplify that later, but for now we can just leave it as 8 over root 2. Now we've worked that out, it's time to address what is the actual question. Because once we have the side length, we can work out anything. We can work out area, perimeter, whatever they want. They want that shaded segment there. Well, to get that shaded segment, you probably guessed this, we're going to do the entire area of the circle, take away the area of the square, and then divide that answer by 4, because there are 4 segments we can see, so we divide by 4 to find just one segment. First, let's tackle the harder one. What's the area of the square? Well, we know the side length is 8 divided by root 2, so we simply do 8 over root 2 times by itself to get the area. That's how you get the area of any square. You times the side length by itself, because all the sides are the same. 8 over root 2 times 8 over root 2 is, do the numerator, 64, do the denominator, root 2 times root 2 is just 2, and 64 divided by 2 is 32. So the area of the square is 32. The area of the circle should be fairly easy. That's pi r squared, and we know the radius is 4. So pi times 4 squared is 16 pi. And if we take away the area of the square from the area of the circle, we get the combined area of those 4 outside parts, those 4 segments. So 16 pi, take away 32, is the combined area of those 4 segments. But the question just wants one of the segments, so we divide the answer by 4. You can draw a line and just put 4 underneath, or you can divide each bit by 4, giving us 4 pi take away 8. And that was a boss level inscription question. If you got it on your own, massive congratulations. If you understood all of that by listening to me, congratulations also. As I said, highly likely to come up in the test. And if any of this was confusing, do re-watch the entire video to make sure you understand it, because there's a good probability this will come up. And I would love to think that it will come up in one of your tests and you'll get it right because you watched this video. Hope so anyway. See you in the next video.